Hi guys, so there is this great article published by Anthropic on what's called a contextual RAG, and I was honestly mind blown by two things by the time I was done reading this article. The first one being how simple it is to significantly improve the performance of our RAG system, and the second one being the fact that this is not already a norm known by everybody and that n8n does not have a built-in node for us to just implement this method directly. So let's just get into it by doing a quick recap on what a traditional RAG is. And actually I'll just do it here first. So in a traditional RAG, we have a document. We break it down into chunks using the chunking strategy of our choice, right? And for each of these chunks, then we convert them into their vector representations, which we call vector embeddings. And then once we have the vector embeddings, we then store it into a vector store or a vector database. To those who don't know what a vector database is, it's a database that basically stores information within a high dimensional plane based on their semantic meaning. So if we were to insert words that have similar meanings, such as cats and dogs, even though they don't have any similarity in terms of the letters in the word, they would still be placed closely to each other or positioned closely to each other just because they have similar semantic meaning in that they are both animals, right? Or in another case, if we have a green apple, which indicates a fruit, and on the other hand, we have apple phone, which they both share similar words within them, they're still going to be placed far away from each other within this high dimensional space just because they have different meanings. And that's how vector databases work, right? Each chunk has vector representations. These representations reflect the semantic meaning of a particular chunk. A chunk could be a word, a sentence, a paragraph, or even different kind of files such as images and stuff. But in this case, we have chunks of text that's within a document, right? Later, if you want to query against this vector database, what we'll have to need is a query. In this case, we have a user query. The user sends a query to the system. The system converts this user query into its vector representation, again, a vector embedding, right? And then to query against the vector database, what we do is we take this embedding and put it into the vector store and determine the position it has within it. In this case, you can see that this vector representation of this query is represented again by a purple circle. And beside this circle, we have two other circles that are placed closely to it compared to these other two circles here. Each of these circles again represent a record, right? A chunk rather. And imagine in this case, we want to return two of the closest record within the vector database. We'll be returning these two data, and hence this is what we're going to have, right? And before we pass it to an LLM, we'll package it as context along with the user's query, and then we'll pass it to the LLM, which will later refer to it and generate a response accordingly. So now what we have here is we're able to provide the LLM with the context from our knowledge base so that it can refer from and provide us with a domain-based answer or response. So this is basically how traditional RAG works, and it's absolutely powerful, right? But although it's very good at fetching relevant information based on semantic similarity, it actually lacks to do so in terms of contextual relevance. And to understand what I mean by that, let's actually go and take a look at Anthropic's own example that they gave in the article. All right, so the context conundrum in traditional RAG. While this approach works well for many applications, it can lead to problems when individual chunks lack sufficient context. For example, imagine you had a collection of financial information embedded in your knowledge base and you received the following question. What was the revenue growth for Acme Corp in Q2 2023? A relevant chunk might contain the text, the company's revenue grew by 3% over the previous quarter. However, this chunk on its own doesn't specify which company it's referring to or the relevant time period, making it difficult to retrieve the right information or use the information effectively. So this is exactly what I mean by contextual relevance, right? It was able to provide us with the chunk that is semantically similar because our query is looking for revenue growth, and we have that in this chunk over here, right? And they're two semantically similar, as in we're looking for revenue growth, and this one talks about revenue growth. But the problem here is that finding semantically similar chunks or records within the knowledge base does not guarantee contextual relevance, because imagine this, we are asking for Q2, but in this chunk here, we are not specifying from which quarter it is. And now imagine we have 10 years worth of earnings report, and that would make 40 quarters. How are we going to know from which quarter that is, right? So this is a huge problem in traditional RAG that could actually cause hallucinations and false responses by the LLM just because we provide it with the wrong context. So that's exactly what contextual RAG aims to fix, and it does it really well. So now let's take a look at an example they provide us with to demonstrate the difference with contextual RAG implemented. Okay, so we have this original chunk here that was inserted using a traditional RAG, which is just plain factual data without any context, saying the company's revenue grew by 3% over the previous quarter, the exact same one we saw above. And below that, we have a contextualized chunk, which is what the chunk would have looked like if we actually used contextual RAG. So here we have the context attached to it before it actually provides it with the fact, right? So this chunk is from an SEC filing on Acme Corp's performance in Q2 2023. The previous quarter's revenue, $314 million. The company's revenue grew by 3% over the previous quarter. So again, this is just tremendous, right? Like I can already imagine the amount of hallucinations that this would prevent, just because we are providing the LLM with contextual retrieval instead of just semantically similar data that may sometimes lack context. All right, now that we understand what contextual RAG does, let's take a look deeper to understand how it does it, right? And after that, I'm actually going to show you this method in action. And I'm also going to be uploading this to my Skool community so you can get access to it. By the way, this is the beginning of my new video series where I'm going to be exploring different RAG methods and strategies, and as I find it, I'll probably be uploading weekly as I explore and experiment with different methods. So you can expect me to post another video where I'm gonna have another workflow down here. So I'll be adding on to this JSON, and I'll be also again uploading them to my community, so also stay tuned for that. Now with that out of the way, let's go back to our diagram and take a look at how contextual RAG works. It starts off the exact same way as we have in traditional RAG, right? So we have a document, we break down the document into chunks, okay, using again the chunking strategy of our choice. But this time, instead of converting it directly into its vector representation, what we do is we actually attach the chunk and the whole document and then pass it to the LLM for it to then add context to it, right? So what it's going to do is it's going to look at the chunk and then compare it to the document, and then it's going to find the context for this chunk and attach it to it. And with that, we are going to have what we call a contextualized chunk, where just like the example we saw in Anthropic's article, we'll have the context first and we'll have the original chunk attached to it, right? Once we have these contextual chunks, we will then finally, again, just like how we do in traditional RAGs, we're going to convert them into vector embeddings and finally add it into the vector store. And after that, we are just able to, you know, do the same thing in terms of querying it against the database, where we'll be sending a query, converting the user query into its vector representation, and then send it to the vector store. And this time the vector store is going to be able to fetch us again the same chunks, but this time along with the context that the LLM can accurately refer to and provide us with a more accurate contextualized response. So now that we actually understand the way these work on a high level, let's actually look at it in action, right? All right, so I'm just going to start with contextual RAG, and I'm not actually going to run this. I'm adding this here for comparison for you guys to actually test it yourself if you'd like, right? And we'll also be able to see the difference in here anyway, because up till this point we are going to run exactly the same way we would for traditional RAG. So we'll actually see how the chunks would have looked like before, or if we weren't to contextualize it. So that's going to be really cool. We'll be able to see how it actually enhances the chunks in real time. And yeah, that's basically it, right? And then after that, we have an agent that's able to work with both of these, since we already saw here in the diagram, right? It's pretty much the same. We are just updating the way we actually insert data and not the way we query them. All right, so for this, I have a Google Drive trigger, right, where we'll be listening for files being created within this directory, and that's this directory here, okay? And then we have a loop. The reason we have a loop here is because in cases where we have more than one files created, we want to be able to handle them properly, right? And you might be confused by looking at this other workflow up here that does not have a loop, but don't worry, it will work exactly the same. This too can handle multiple files at once. The reason I had to add a loop here is because of these two nodes here, which kind of bridges and merges the other files that's being processed, which would otherwise be processed individually, like the one here, right, separately. But in this case, when we do summarize, what it does is it actually combines all the documents from all the files, so it doesn't work great. And yeah, I just wanted to clarify that. So this is also going to work exactly the same. The only thing that's different here is between these two workflows is that what we are doing in the middle, right? Here we are adding another context to each of the chunks. And here we are just converting the document into text and passing it directly into the vector store. So that's basically it. And with that out of the way, let's actually continue. So we have this loop here, and next we have a namespace classifier, which I added just to, you know, follow best practices and encourage them, even though this is just us looking into different strategies for RAG. I would still like to follow the best practices. What this does is basically, in this case, we made it simple. It's going to look at the title of the document and determine whether or not it's a financial based or fact based document, right? The reason we do this is to categorize the indexes we create within these vector databases so that we can remove noise. So for instance, if we want to look for something related to legal documents, we wouldn't want to look at frequently asked questions or financial related data. Or if you are looking for something regarding technical support that falls under frequently asked questions, then we don't want to look at financial data, but the document that actually is relevant to that particular query, right? This helps us to query a database more efficiently by filtering it based on the namespace or category that we are trying to find relevant information from. Okay, so that's pretty much what this is doing. And then we have, what we're doing is we are extracting the information, the details from this file, and we have file ID, file type, file URL, file title, and the namespace. And then we have a switcher which decides what kind of file it is, and we have two, one for PDF and one for just a regular text file. And you might be wondering why I don't have Google Sheets or Excel or any other tabular based extractor here. The reason is because this is particularly more effective in for unstructured data, because as for tabular structured data, usually all the information is contained within the row itself. It just makes it much simpler for us to just insert it into vector database and does not really require this, even though we can. But the reason I just added this is because this is that needs this the most, right? So we extract the file, and there's this set node for this just to create a unified interface. So we are adding the content into this data field, which in this case already automatically corresponds to data. And then we have another unifying set node that does the exact same thing. We're just creating another field called data. So this LLM chain will be able to refer from when we're trying to compare the chunks against an entire document. Then we have a recursive splitter. This is pretty much the exact same thing as what we have here with built-in splitters. So you can see that here we have three different types of splitters, right? That's exactly what we're doing there. But because n8n does not provide this as a standalone node, I had to create my own code node, or rather I had to get ChatGPT to create it for me. And that's exactly what we're doing. So we have chunk size of 1000 and chunk overlap of 200, right? And then we go into the split chunks. The split chunks, what it does is it basically splits the chunks that we create using the recursive splitter node and then passes it into this LLM here. That's, by the way, connected to a Gemini chat model, which makes it super cheap to do. This model is actually really good in creating context. It's powerful enough for this thing, and it's actually a really powerful model in general. So we have this basic LLM chain. Let's take a look at the prompt that we have here. The document, the whole document that we are passing to it, right? And here is the chunk we want to situate within the overall document. Okay, the chunk, all right. And after that, we are giving it the instructions of what it's supposed to do. And this is, by the way, different from the one Anthropic provided us in the article. And the reason to that is because, by the way, they encourage it too, because what they have here is more generic, right? So they have here, which is really effective. But what I noticed in my particular case was that, and I'm going to show it to you in a bit, is that there was also a problem regarding faulty chunking, right? Where it literally cuts the data from 854% to 54%. And that's just horrible. Honestly, that's just a perfect way to make LLMs hallucinate. And that's what this thing exactly solves. So we're going to be actually seeing it in action, because the document here has that problem when we actually chunk it. I mean, the document doesn't have the problem, but our chunking strategy coincides with the amount of characters in this document that causes this problem. Anyway, I could have put that in a different way, but yeah, so we have this instructions here, right? Pretty exactly what we want. So please provide a short, succinct context. After all of this is done, we fill in the following format: succinct, context, and original chunk or corrected version if necessary. And the reason we have this is because, like I said, 854% to 54%, no, we don't want that. And this is what exactly it's going to fix for us, only if necessary, right? And once we have all of that, our LLM is going to be contextualizing all of the chunks. Okay, so we have all the contextualized chunks, and then we have this summarize node that's going to concatenate all of this array of chunks into a text. And I had to do this so that I can actually use it with this pinecone vector store node that n8n has built in, right? Otherwise, this is an unnecessary step, but in this case, we need this. So what we have is we convert the whole array of chunks into a single block of text, and then we have this split as a custom separator, and I'll show you what this is going to be used in a bit. Actually, let's just go ahead directly now, and we go into the vector store node. By the way, if you don't know how to set this up, just click on this hyperlink that says docs here. It's going to walk you through exactly how you can create an account and how you can use this node. So I'm not going to waste your time to show it here. So we have this pinecone vector store, and you can see we have a namespace thing which we are using from the one we classified using this node, right? So this classifier is going to specify it for us, and that's where we are actually using this namespace. So when we add the documents or the chunks for this data, we are adding it under that particular category that is determined by that classifier node. And then we are using OpenAI's embedding here, so nothing special. OpenAI's text embedding tree small. Then we have the document loader here, so the type of data is JSON load all input data. And you can see here we also have metadata, right? Again, I'm following the best practices. In this case, we're just adding the file URL to the chunk so that if we ever wanted to ask or wanted to learn where this chunk was from, we will be able to see it, right? So it could be used as a citation. And another cool thing you can do with metadata is adding the created date, so you can further filter it by doing things such as filter it based on things that has been created after or before a particular date or anything. So you can use metadata for learning additional information or even filtering, right? So this again is the best practice and why I wanted to include it here. And finally, we have the character text splitter. In the character text splitter, this is where we are using the split separator that we had in the summarize node. What we are using this for is simply to split by using this separator here. So the one we created here in this document, as like I said, a workaround, we added a custom separator. So every time it added the chunks, the array of chunks, and concatenated together, right, it will add this splitter under it. So now what we're doing is we are basically intelligently using that same separator to make it work with the pinecone's node here. So, and by the way, this chunk size here does not matter. Even if I added 5,000, of course, unless if I added 100, it would, but the higher limit doesn't matter since we are just splitting it based on this one here. And I didn't add an overlap since we are already doing that in the recursive splitter code node here, as you can see, chunk overlap, right? So that's pretty much what this does. And everything here is exactly the same. Like I said, the only difference is this part here where we are adding context. Apart from that, everything here is doing exact same thing. We even have the same category, so that's why we are able to use it with our agent here. But with that out of the way, let's actually test this baby out here and see its true power. All right, so for this, I'm going to be using NVIDIA's fiscal 2024 second quarter earnings report, right? Since I'm also an investor in it myself and not really happy of how it's going recently, but it's bouncing back. Anyway, back to the topic. So we have a perfect example of unstructured data. So we have text here with bullet points, and then suddenly we have tables, and then we have the following, again, text and etc. So we're going to be using this to showcase the strength of contextual RAG, and let's actually just get into it without further ado. So I'm just going to go ahead and click on test workflow, and we're going to see what happens after that, right? Let's go ahead and click on it, and it starts working. It got our report or our file. Right, it started processing. It's a PDF, so it went through the right route. And now we have all the chunks split. This is what it would have looked like by using this simple regular recursive splitter with traditional RAG without contextualizing it, right? And as it's actually processing it, we have around 30, I think, 30 items here. Oh, never mind, I wasn't able to explain before it ended. But yeah, so this is the chunks we have split, right? And then this is, I think, the one we have, yeah, exactly. This is the one that we have contextualized. So this is the raw original chunk. NVIDIA announces financial results. And then take a look at the second chunk we have here that says 54% from a year ago. Oops, how did I get here? Let me go back. So it says 54% from a year ago and up 202% from the previous, right? But take a look at what this exactly is. And the reason we got this is because we are using chunk overlap, right? So we have the chunk overlap of 200 characters. Take a look at this. In reality, it's up 854% a year ago instead of 54%. So you can see how bad this could actually be, and just gave the LLM a huge reason to hallucinate. And now imagine in a case where we write a query that returns this chunk here instead of this, is going to just refer to this value here in order to respond to the user, and that's obviously bad. But when we look at the second chunk here, or the contextualized chunks to the right, you can see how we actually add on top of it, right? So we have NVIDIA announces financial result. Here it didn't require much of a context since it already includes context on its own since it's at the beginning of the file, right? So it just added NVIDIA's Q2 fiscal year 2024 financial results. And in the second chunk where we had a problem and where it could have caused a problem with regular chunking, we have this one now. We have NVIDIA's Q2 fiscal 2024 financial results, again including context, including GAAP and non-GAAP, earnings per share, and CEO commentary on AI, followed by shareholder returns, right? And not only did it add context to this chunk, it actually rectified the corruption that was caused by faulty chunking. You can see that this time it does include 854% and even more to make it even more complete, right? It was able to infer this, which is super cool, because in this case here we are just saying 54% from a year ago, and now we are not only saying that, but we are also including another part of this thing that's absolutely necessary to complete this part of the sentence. And that is why this thing is just amazing. I was, like I said again, mind blown by how this is not the industry norm, where even on n8n it should be part of the built-in node that people should be able to just implement directly, right? This is no question. We're basically adding a layer of intelligence to our chunking process. Let's continue looking at the other parts, like the table parts, right? So here we have, what do we have? This is the second chunk, third chunk, right? And let's take a look at the third chunk, 1, 2, 3, and then let's actually take a look at the fourth chunk, which is where the table gets broken. Okay, fourth chunk is like this. So here, gross margin 70.1%, 64%. So we have nothing here. We don't know from which quarter this is from, right? Can we? Yeah, we do see that. Okay, but we are seeing for the next table, which is part of this chunk and not the one that was broken from the previous table. The previous table started in the previous chunk above here, right? So this one, it does not know exactly. Here we have GAAP, right? Non-GAAP, but it would have to infer that the one above is GAAP, and obviously that's bad. And in our case here, what's happening is the contextualized chunk has the context saying that this chunk presents NVIDIA's GAAP and non-GAAP, making it much easier for the LLM to actually infer that the one above obviously is part of GAAP, right? Or GAAP, however it is pronounced. And actually we can also instruct the LLM to include complete tables, right? Imagine if it gets this chunk, it finds that this table is not complete, just complete it. And the next time it comes here, it's going to find that this is the continuation of this table. Just complete this as well. I wouldn't mind duplication of data than, you know, in cases where we would otherwise lose context. So this is a great trade-off. So we can also include that in our prompt, right? And in that case, we would have complete tables instead of just like this, even though this is already pretty good since we're passing it the context again, telling it what table it is from. But yeah, in hindsight, we could also benefit from it outputting the whole table or including the whole table in the chunk. And yeah, when we look at the other parts, you can see that now all the we have the context that's just going to help us, right? This is just much better than what it would have looked like otherwise without contextual chunking. This way, it's going to help us tremendously in reducing the amount of hallucinations and also the error rate, which Anthropic specified to be 35% based on their research. So then we get the contextualized chunk, and like I said, convert it into a single document with splitters that we specified that should look like this. Let me actually copy. Try to look for it. You can see it's everywhere, right? Then we pass this to our Pinecone vector store node, which is going to pass it to the data loader, and that data loader is going to use the splitter that's going to help us split the chunks every time it comes across this, and the final result should be something like the one we see here. Let's see. All right, so I'm back and I take back my word. So apparently it does matter the chunk size you add to it, and the way it works is like this. It is working, it is splitting it based on this, but from what I understand, what it does is it waits for the chunk size to reach over 5,000, and only then it breaks it in that next split. Okay, let's take a look at an example here. So we have the first item here, right? So I go down all the way down and we can see that it hasn't even split once despite having seen 3 of these things, but then it splits exactly at Outlook. And let's take a look at which occurrence that is exactly, right? So when you go to Outlook, you can see that the next thing after Outlook is actually split, and that's what it's split for. So what I understand is it waits for the chunk size to reach 5,000 and then it splits the next time it sees the separator. So what we can do is simply just lower this to, you know, let's say in our case we were 1,000, right? But with overlapping, I'm just gonna say 1,200. We also obviously have the context, but since this is going to split the next time it sees it, it should work fine, and we should be able to have an accurate, you know, mapping of our created documents here. And let's actually test it out now. Funny thing is, the first time I did it, I reran the whole workflow. Then I realized like I didn't even need to do that. I could have just reran it here, and that's what I'm doing now. Right now, let's take a look at the result. All right, a new computer era has begun. Let's see if this is correct. Okay, exactly. This is what we have, right? So we have this all the way from here to here, and you can see that we broke it exactly there. So a new computer era has begun. And the second item is going to be dividends, and that's what we did here. And then the third item is going to be up 202203, right? Where is that? Let's see. So yeah, up 203%. So basically solving the problem that we had here, and the lesson that we learned is that it does matter the chunk size you specify here. All right, so now we have everything in our vector store, and we can actually start using it using our RAG agent here, right? And let's just make sure we are connected to the correct database, right? Contextual RAG, perfect. And as you can see, we have the filter to decide which namespace we want to use. We have either FAQ or financial namespace, right? Let's actually test this agent here and ask it a question from the document. Let's see what we have, and I'm going to tell it to find me, let's say, the gross margin of, or the operating expense of Q2 financial year 2023. Let's go over to our RAG agent. What was the operating expense for Q3, right? Q3 or Q2 2023 of NVIDIA. Let's see. So it hit the pine cone, but no execution data available. What do you mean exactly? I'm not sure what that means. All right, so bad news, guys. Apparently we are not able to use from AI for this thing, for this sub node here. So I had to, you know, write it manually myself. I would like to call out to n8n to please fix this bug. But apart from that, I was able to get it to work, right? I asked it what are the operating expenses of Q2 2023. It was able to give me the right answer, right? Accurate answer, more importantly. Then I tried my luck again by turning it again into from AI, but with no luck. So I'm just going to keep it this way. And let's actually take a look at what the database looks like, right? Since we already have it, you can see that we have namespaces here, and since we only uploaded financial based data, we only have this one namespace here. And when we browse for the chunks here, we have everything. So remember, we added the file URL, right? This is that file URL there. We are able to actually cite this, tell it, where did you get this from? Okay, then we have the text. So again, we can see the context attached at the beginning, right? And also for all of these basically. And this is what our database currently looks like. And let's try another question actually, and then we'll finish off this video. Let's see what would be a complicated thing to ask. All right, so we have this one here where it says NVIDIA Corporation condensed consolidated balance sheets. And we can ask a question for one of these, you know, items here. We'll try that with this, and I'll say, what is the property and equipment net for January 29? Let me see. Condensed balance sheet. Let me just, you know, add this. I'm sure it's going to be able to find it for us. Anyway, let me just make sure I'm using the manual namespace. All right, let's see what happens. Exciting. Net for January 29. Okay, let's see. So it's going to hit the Pinecone database, and hopefully we will get the right answer. Really exciting, to be honest. For January 29, the property and equipment net is reported at 3.807 million. I honestly don't remember, so let's take a look. And perfect. Even though we didn't even instruct it to include the whole table, we were actually able to find the exact record, the exact value from the exact record. So I'm really surprised by this, and like I just can't emphasize enough on how beautiful this is. And to be unbiased, we are getting 10 of the items, so we are pretty much returning most of the documents anyway, so I don't want to be that proud. But Anthropic actually recommends to return 20 items and not even 10 in production. In this case, even 10 is a lot, so we couldn't really see how great it works, and we would need much bigger data sets for that. And but I'm sure you understand the power of this already, right? So I probably don't have to show it to you guys explicitly. You can test it out yourself and see how well this works. And it's just obvious, like just from the way we see how it contextualizes the chunks, you can understand how it's going to prevent hallucinations, and I think that's what really matters. And like I said, guys, this is the end of the video. By the way, I'm going to be uploading this to my Skool community, and this is going to be a new series where I'm going to be testing out new RAG based systems that I explored. There are many kinds, like there is graph RAG that involves knowledge graph, and we can in our case even combine it together with this contextual RAG here. And as a matter of fact, actually inside the article Anthropic shows, it also implements this thing here. They additionally implement a different layer of indexing. It doesn't only use vector embedding, right? So this is what contextual embedding on its own does, but with BM25, like I said, is another algorithm. They combine both of these together. The error rate goes down even further, and this is what I'm probably going to be working on actually, and post a video on this next week, so stay tuned. But this is already mind-blowing on its own since it's really simple to implement. I hope you guys enjoyed this video, and with that, take care.